All right, here's our current structure. We have this fairly complex hierarchy. At the top, we have our remote control class. Below this, we have 3 classes, the advanced remote control, as well as 2 implementations for Sony and Samsung. And we have the same structure under this advanced remote control. We have 1 implementation for Sony and another for Samsung. Now, the problem with this structure is that it's very inflexible. So if tomorrow we want to support a new type of remote control, let's say a remote control customized for watching movies, we have to add a new class here called Movie Remote Control. And under this class, we should have implementations for every TV brand that we support. So if we support 10 TV brands, we should add 10 extra classes to this hierarchy. By the same token, if tomorrow we want to support a new TV brand, let's say LG, we should add 2 new classes to this hierarchy. One is going to end up here. It's going to be called LG Remote Control. And we're going to have another class here. It's going to be called LG Advanced Remote Control. So every time we support a new type of remote control or a new TV brand, we should add a bunch of new classes to this hierarchy. And over time, this hierarchy is going to get very complex and unmaintainable. Now, the reason we ended up with this structure is because our hierarchy is growing in 2 different dimensions. Let me color code these classes so you know what I'm talking about. So on the one side, we have these blue classes. These are all about features of a remote control. So we have a basic remote control and an advanced remote control. So this is one dimension. And we have this other dimension, which is all about implementation or TV brands. So we have classes for Sony, Samsung, and so on. So to simplify this hierarchy, we need to break it down into half. On the one side, we should have this hierarchy, which is all about the features of a remote control. So in this hierarchy, we have 2 classes, remote control and advanced remote control. And we should have a separate hierarchy, which is all about implementation. So in this hierarchy, we're going to have this remote control class and an implementation for Sony plus other brands such as Samsung and so on. Now for clarity, let me rename this class from remote control to device and Sony remote to Sony TV. That is more explicit. So now we have 2 completely independent hierarchies. Now we should add a composition relationship between the remote control and device classes. So a remote control targets a particular device. In practical terms, that means in this class, we're going to have a field of type device, and we're going to initialize this field using the constructor of the remote control. So when we want to create a remote control object, we're going to give it a real device implementation, such as a Sony TV. Now, what is interesting here is that nowhere in this hierarchy we see this class. We don't care what concrete device implementation we're talking to, because we're simply talking to this abstraction, which can be an abstract class or an interface. So in the turn on method, our code is going to look like this. We're going to call the turn on method of this device, which is an interface or an abstract class. So with this new structure, if tomorrow we want to support a new TV brand, we simply add a new class here, like LG TV, that implements the device interface. Our feature hierarchy is not affected because this hierarchy is only dependent on this device interface and not these concrete implementations. So if you want to support a new TV brand, we don't have to add several new classes to our hierarchy. We simply extend this hierarchy and add a new class to it. Our feature hierarchy is not affected. By the same token, if you want to support a new type of remote control, let's say a remote control for watching new movies, we simply add a new class to this hierarchy. Our implementation hierarchy is not affected. So with this structure, we can combine various classes from these 2 separate hierarchies. And this is what we call the bridge pattern. The reason this pattern is called the bridge pattern is because of this relationship between these 2 hierarchies. So this relationship is acting as a bridge. It connects 2 completely independent hierarchies. So with the bridge pattern, we can build flexible hierarchies that can grow independent of each other. In this example, we started with this complex hierarchy. So as I told you earlier, this hierarchy is growing in 2 different dimensions. We have a feature dimension and and an implementation dimension. Now, to simplify this hierarchy and make it more extensible and maintainable, we ended up splitting it into two separate hierarchies, a feature hierarchy and an implementation hierarchy. So this is the bridge pattern. Whenever we have a hierarchy that grows in two different dimensions, we need to split it into two separate hierarchies and connect them using a bridge. So next, I'm going to show you how to apply the bridge pattern to make our hierarchy more extensible and maintainable.